And when we first introduced the idea of having a slide valve open flame ignition show, people began to wonder, well, what is that, and will it be what we'd like it to be? As I see it today, with all of the nice pieces that we have collected here, and many more to come, I think this is going to be a historical event that will be remembered for years, and particularly amongst the collectors. This puts together the nicest collection of internal combustion engines I believe that could ever be assembled. John and I have been working on this, talking to people, collecting data, and putting this thing together, and it's come together very well. And I'd like to introduce you to John Rex.
Thank you, Nate. We've been very fortunate in being able to contact engine owners of these exotic and rare flame ignition and slide valve engines and pre-1895 engines, contact owners from all over the United States, and we have examples of engines from California that have been taken in from collections in California, Michigan, Texas, Pennsylvania, Connecticut, Massachusetts, and I think this is the finest example and some of the finest collection of slide valve and flame ignition engines that will ever be assembled, probably at any show anywhere. And with that, I'd like to take you over to the powerhouse and introduce you to John Wilcox, who will show you the world's oldest operating internal combustion engine. And so we're going over here to take a look at the powerhouse. So this is the powerhouse now that we're in, and I'd like to introduce you to John Wilcox, co-founder of the organization, who will show you the Otto and Langen and other engines.
Well, John, welcome to the powerhouse. This is one of our earlier buildings here at the museum, and with the exception of the first exhibit I'm going to show you, everything is on at least extended loan, so it'll be here for several years. We have 3 of the original 4-stroke slide valve flame ignition engines in here. And we also have a very early engine, which is an Otto and Langen free piston atmospheric engine. Now this was Otto's first engine before he developed the 4-stroke cycle in 1876. After 7 years of extensive effort starting about 1860, he developed this engine, which is a free piston engine. It was put into production in 1867, though we only managed to build 7 of them in that year. And the piston works vertically in this beautifully fluted column. The charge is pulled in underneath the piston and lit without compression, and it blows the piston upward. And it's a free piston because it's not doing any work as it goes upward. It just throws the piston up so hard that by the time it stops, it's pulled a lot of vacuum in the cylinder. And then on the way down, the vacuum works and the weight of the piston works and couples to this shaft through a freewheeling clutch, through a long rack here, which I can show you here. See, this rack is attached to the piston and it goes up that high if you get a full charge in there. And then on the downstroke, it drives the wheel. And when it gets down about to there, you get back up to atmospheric pressure, and a valve opens down here, and from that point on, the weight of the piston is simply pushing the exhaust out. And when it gets to the bottom, it trips the mechanism to start a new charge. The piston is lifted mechanically for about 4.5 inches to pull in the charge, and then it's lit and everything starts again. Now, Otto built these engines until 1876 when he developed his 4-stroke cycle. And it was the most efficient engine on the market through that period because of its rapid expansion. There was very little heat loss to the water jacket. The competing engines fired without compression and had pistons and connecting rods more like modern engines, and they didn't have the rapid expansion, so they used about 3 times as much fuel by loss of heat to the water jacket. Now, this particular engine is the oldest internal combustion engine in the United States. It's also a running engine, and we're going to show you how it runs. These flame ignition engines work best if we use hydrogen as a fuel because it's the closest we can come to the city illuminating gas that they were designed for. So Nate's going to turn on the hydrogen bottle for us. Nate? And I'm going to light a pilot light, which is the first part of the ignition. A little bit of a pop there is the hydrogen lights. And we have fuel, so it should go. Now you can see the freewheeling clutch operating. Power is delivered during the fast part of the downstream. The clutch is right in here and locks up at that time to drive the flywheel, and power eventually is delivered through a flat belt pulley over here. The engine puts out only half a horsepower. The auxiliary shaft over on this side has a drive ratchet here, which engages when the piston reaches the bottom of its travel. The piston depresses this pawl right here, allowing the ratchet pawl to fall in and driving two eccentrics. The large eccentric raises the piston the first 4.5 inches to draw in a charge. The second eccentric operates the main slide valve. The valves are down here. This is the main slide valve. It controls the intake functions and ignition, and exhaust also goes through it. This second slide valve controls the release of the exhaust, and it's operated by a cam on the piston. So when it raises, or when it goes down rather, that happens as the piston falls at a certain point in its stroke. The exhaust ports through the main valve are open where it parks, and exhaust comes out and around a pocket in the back of this and out this pipe. And we're controlling the engine now by hand cock. This is the way all of the early autos were fixed up. That's throttling the exhaust. If it's open, the engine will fire more often. And if it's shut, it takes longer to push the exhaust out, so there's a longer interval between firing. It doesn't go much faster if it fires more often because the piston just doesn't catch up to the peripheral speed of the shaft, but it would deliver more torque. The flyball governor you see on this engine is not original, but it does duplicate something that Otto did in a little bit later. We believe that this particular engine is one of the first 7 he built in 1867. He gave one of those to John Roebling, who built the Brooklyn Bridge. Roebling had been to Europe and visited Otto's factory and was impressed with his engines. And Otto gave him one and said, "Here, take it home, show it to your engineering friends. Maybe somebody in America will want to build this engine under license or want to sell it there." Roebling brought it back to New York City, and this particular engine came from the Stevens Institute, which was founded in 1868, and it was in Hoboken, New Jersey, just across the river from New York. We believe that Otto gave the engine to Stevens, who was a well-known engineer at that time, and it was in the Institute's museum for many years until the building burned down around it during the Second World War. and it was rescued from that situation by one of the first engine collectors, Mr. William W. Willock of Chestertown, Maryland. It was in his collection for many years, in rather poor condition, and it now belongs to the Rough and Tumble Engineering Historical Association of Lancaster County, Pennsylvania. Mr. Willock willed it to them at his death, but previous to that, the Rough and Tumble organization had borrowed it for a couple of years. Their then president, Amos Stauffer, did the cosmetic restoration on it. I did the mechanical restoration. So it's been running since 1978. Now you can see how the flame ignition works. There's an external pilot light, which burns all the time. And that's lighting a second light within the thickness of the slide valve. This line here is feeding the external pilot light. This one is feeding the light within the thickness of the valve. And as the valve moves upward, the chamber within the valve that contains the second pilot light is first isolated from the atmosphere and then open to the cylinder so the flame can flash in. That extinguishes the light within the valve, which then has to come back down and be relit from the external pipe. This worked so well that I had to do very little to it to make the four-stroke cycle work later on, where the flame ignition had to work against pressure in the cylinder. But it's somewhat easier here because the cylinder charge is simply at atmospheric pressure at the time it's lit, so it's not so hard to get the flame in there without losing it. But Otto realized very early on that he didn't need the second slide valve, but all he needed was a check to let the exhaust come back out when the contents of the cylinder got up to atmospheric pressure. And he did away with this and just put in a check valve, still using the hand cock there. This is the only engine that exists that has the second slide, although there is one in Germany that has this boss cast into the cover, but it's never been machined for it. But his flyer for the 1867 Paris Exposition does show the second rod coming down, so that was his first design. He built about 700 of these nicely finished fluted column octagon base engines, and then in 1872 the engine was redesigned for cheaper production. They did away with the second shaft, and the column was pretty much just a straight, unadorned casting from then on. In total, about 5,000 of the three-piston engines were built. They were built in Germany by Otto and Langen, which was incorporated in 1873 as Gas Motor and Fabrik Deutsch. Otto was a director, and several of the Langen family participated and took over management functions in the company, while Otto remained more of the engineer. We're indebted to Rough and Tumble for having the engine here. It can be seen every year operating there in August, usually the third weekend of August. This is in Lancaster County, 12 miles east of the town of Lancaster on Route 30, the town of Kinzers. Nate, I think you can turn the hydrogen off now, and we'll go on to the next piece. We blow a little bit of the water out of the bottom. The engine stops. One problem with the vertical cylinder is that it does collect lubricating oil and water. Occasionally when it's idling this way, it has to be opened up to blow out. That's what the little can here is for. It's collecting the goop. Well, now if you'll come along, we'll show you Otto's next development. Now, we mentioned that Otto's free piston engine was much more efficient than anything else on the market, but the problem was it was extremely noisy, especially if it was up on the second floor of some old wooden building. You can imagine this shaking when the piston was thrown up, being transmitted through the whole building. But still, because gas was very expensive at that time, people put up with the objectionable engine. But Otto himself wasn't happy. He wanted to do something better. And early in his development, he had tried to build an engine that operated on a four-stroke cycle. He had the idea that he could have a piston in a cylinder which moved back to take in a charge, came forward to compress it, fired then under pressure, and then expanded and exhausted. So it made 4 strokes and 2 revolutions to complete its cycle. He tried to build such an engine between 1860 and 1862, but at that time he didn't have the ignition technology to fire against compression, and he just couldn't make it work, and he gave up and went to the free piston design. But in 1876, he revisited some of his earlier ideas, and he built an engine which first ran in May of that year, which operated on the 4-stroke cycle and looked very much like this one. We said that the free piston engine in its later years was built by Gas Motor and Fabrik Deutz. This is a Deutz engine. Otto was still a director of the company. Many of the Langen family members were also directors. They were a wealthy sugar mining or sugar refining family in the Cologne area, and they were the financial backing, while Otto was the engineering genius. This was the first engine to have 2-to-1 gearing. What we call the side shaft, or the camshaft, is driven at half the crankshaft speed. It had a slide valve similar to the free piston engine, which controlled the ignition and intake functions. And this is the slide valve right in here, driven by this crank on the end of the side shaft. It had a poppet-type exhaust valve in the box on the far side, worked by a cam in this area and a rocker going underneath. It also has a fuel valve, which lets the gas in, which then goes through the slide and into the cylinder. The purpose of the fuel valve is just to allow the engine to be governed. The centrifugal flyball governor in this area shifts the cam which operates this valve, so that when the engine goes too fast, it doesn't let the fuel in anymore. The handcock up here is simply for regulating the mixture, whether it's too rich or too lean or whatever. This slide is very similar to that was used in the atmospheric engine, but it has the additional problem that the charge in the cylinder that's trying to be lit is at higher pressure than the ignition flame. So a certain amount of development in bleed grooves and so forth was required to get the flame chamber in the valve up to cylinder pressure slowly enough that the flame wasn't extinguished. And then a much larger port opens, which has sufficient area that the flame can flash back into the cylinder. But again, it's the principle of an external pilot light, which is in this area and burns all the time, and the second pilot light within the thickness of the valve. Well, I believe we can start this up. We have the fuel turned on now. Again, we have hydrogen to the ignition flames. And we have to light the pilot light, which comes on with a little bit of a pop. And we have to set the mixture for starting. Maybe just a little more. Have to be careful not to lose it at this point. Now the engine's on the governor. It fires only when the gas valve is open. The governor is shifting this cam sideways so that it misses the follower when the speed is excessive. All of the early slide valve engines used the crosshead design to take the side thrust off the piston. This was a holdover from steam engine practice. The gears sound noisy, but that's probably because the engine's sitting on this big wooden base that was built by the Ford Museum. Makes kind of a resonant chamber for it. This engine was brought from Germany by Henry Ford in the era of 1925 to 1930 and now belongs to Greg Johnson of San Diego, California, and is on loan to the Coolspring Power Museum for at least a few years. But Greg did the restoration work on it and got it running, did a beautiful job. It's actually one of the later slide valve engines that Deutz built, but it follows the original design of 1876 exactly. They didn't change much on them through the years. Driven device is the cylinder and slide oiler that have reduction gears and wires that dip in oil in the bottom of the pot and come up and wipe across the ends of pipes. This pipe leads to the cylinder, that pipe leads to the slide valve. Pop you hear around the head of the engine is the pilot light within the thickness of the slide being relit as it comes across to the external pilot each cycle. This is silent engine for obvious reason, since you've seen the noisy one run. It was very much a success. Everybody who saw it was just amazed at how much nicer it was than the three-piston engine. And finally, he had good success in getting manufacturers in other countries to build these engines. We'll shut this off now, and it'll slow down. Crossley Brothers in England had already built some of the three-piston atmospheric engines under license from the Deutz company, and they were overjoyed with the four-stroke cycle and got into immediate production. They were building engines as early as 1877 on the four-stroke cycle. And we have one of these right here we can show you. This is a 3.5 horsepower Crossley Brothers engine, a very early production. We know the serial number sequences on Crossley Brothers, and this engine was built in 1879. It's the oldest operating four-stroke cycle engine in America. There is one earlier Crossley in the Ford Museum collection, but all of the early ones were the 3.5 horsepower size. This one belongs to Nathan Littlebridge, who you've already met, one of our exposition directors. The Crossley design was different in appearance, but identical in principle to Deutz. The 2-to-1 gearing drove the side shaft. The vertical governor is similar in principle to the hanging governor of the Deutz, but Crossley's just needed to redesign everything to bring their own English pride into it. There were also licensees in Austria and other European companies which followed the Deutz design much more closely. Crossley Brothers built these engines up until about 1890. They built some smaller ones, like the one that you see over there. That's a side crank Crossley Brothers, about an 1884 design, 1/2 horsepower, but still a slide valve engine. Actually, the earliest engines were some of the larger ones, and then later on they developed these smaller sizes for little shops where, before the advent of a convenient gas engine, the work might have been done by a hand crank or a foot treadle. Gas engines were often used where the power requirement was intermittent and it wasn't desired to fire a steam boiler all day long. Also in 1876, Otto finally succeeded in finding an American licensee. He did it pretty much from Germany. The Schleicher-Schum Company was established in Philadelphia. Mr. Schum was a director of Gas Motor and Fabrik Deutz, went to America to help set up the factory and stayed for only a couple of years. The Schleichers were cousins of the Langen family, and they immigrated to Philadelphia with the intention originally of building the three-piston engine, but just about the time that they got here, the four-stroke cycle engine came along and they took that up instead. We have one of the original Schleicher-Schums over in the next building that we'll show you now. I'd like you to meet Preston Foster. Hi, Preston.
Hi, John.
Preston is past president of the museum and still on our board of directors, and he's the caretaker of this beautiful building, which houses engines from the Calvin Sousson collection. And in particular, it houses a very nice early Schleicher-Schum slide valve engine, which again is one of Henry Ford's engines. As you can see, this is very similar to the Deutz that we ran over in the powerhouse. The Schleicher brothers and Hermann Schum followed the Deutz design very closely except for the rod bearing. One way you can tell a Schleicher Schum is by the full marine brass rod. The Deutz has a steel spherical shape here, which is integral with the connecting rod. There are other detailed design changes, but that's the most obvious one. Want to start this up for us, Preston?
Sure, Ron. Already have my hydrogen flame burning. Get the slide warmed up. We'll see if we can have some motion.
Now this one's actually running on hydrogen, while the Deutz we ran had propane in the cylinder and hydrogen only to the ignition flames. A little bit easier to start than put hydrogen everywhere. Beautiful job, Preston. This engine went into production in Philadelphia in 1877. This particular one was built about 84, and production continued until the late 80s, when the American design departed somewhat from the German practice, and particularly the side shaft drive went to a spur and bevel design. We'll show you one of those over in the other building pretty soon now. The Schleicher brothers remained in America. Jacob changed his name to James. He and his brother Adolf managed the factory and owned part of it until their retirement in 1894. At that time, they sold their interest back to the parent Deutz company. And the name of the company was changed to the Auto Gas Engine Works. And we have quite a few Auto Gas Engine Works engines in the hands of collectors around the country, but not very many which are old enough to carry the Schleicher Schum name. The Auto Gas Engine Works remained wholly owned by the parent Deutz factory until the time of the First World War, when it was expropriated by the American government and eventually sold to Superior Gas Engine Company. This governor has fly balls. What you see here is a weight that rests on top of the fly balls and actually regulates the speed of the engine. If you take the weight off, as we did with the Deutz, it will run about 100 RPM slower. It's shifting the cam so that the fuel valve isn't open when the engine gets to excessive speed. At low speed, the cam will go off the other side of the follower, so the engine is safe from stopping with the fuel valve open. That's why it had to be blocked up for starting, so that the fuel valve would open when we cranked it. Thank you, Preston. You did a wonderful job in restoring that engine. If you all want to come along now, we can all go over to our new exposition building and see some of the other Schleicher-Schum designs. We'll take you now into our Harvey Exposition Center. This building was erected this spring specifically for the exposition, and most of the displays have come in just for this one weekend, and we'll be going back home, and after that it will become one of the ordinary museum buildings full of our own displays. But it was put up by Paul Harvey at his own expense as part of the enterprise here for this particular show. Now, in the other building, we showed you the original 1877 Schleicher-Schum that followed the German design. This is a Schleicher-Schum from the late 1880s where the American design diverged from the German design. Notably, this engine has the spur and bevel drive for the side shaft, which eliminates the long overhung section and allows the main bearings to be set close together for a stronger crankshaft. They found the crosshead was not necessary. The trunk piston works quite nicely in gas engines. And the flyball governor was eliminated in favor of the pendulum type used there, which is easier to make and works quite nicely. This engine belongs to Nathan Lillibridge. It was restored by John Rex, and all this talent is right here. So, John, why don't you tell us about the history of the engine and what you did to it?
Well, thank you, John. This engine came from the Blake Machine Shop in Weston, Massachusetts, and Blake was responsible for inventing Blake's transmitter, which was a form of microphone that was important to the communication and telephone industry. And as a result of his success in selling that and many other patent successes, he was able to become quite wealthy and afford this sort of engine for his shop. This engine's 4-horsepower auto. It cost $680 in 1888, according to the auto literature. An equivalent steam engine of the day would be a tenth of that price. The engine fell into disrepair after 1960 and suffered a lot of abuse and water soaking. And one of the things that we found when the engine was obtained was that the rod brasses were missing. This whole stub shaft with the large spur gear and the small bevel gear on it were missing. So those all had to be fabricated. Many other parts had to be fabricated for the engine. There was a lot of machine work to remove surface pitting and rusting. And Nate asked me if I could restore that, and I told him it would take a year. In reality, it took over 2 years. With that, I think we can start the engine, and Nate Lillibridge will start the engine, and I'll do some cranking back here on it to give him a help. Here you go, Nate.
Thank you, John. John is turning on the hydrogen. We'll find a match and prepare to light the burner. The usual pop. We'll check and make sure that the governor is in position to hit the fuel valve during the initial cranking operation. Compression release mechanism is in place. The burner's going, water's on, and I guess we're waiting for John. Fine job. As usual, as you've seen before, the auto engines start very nicely. right there, you might as well take note of the governor that they mentioned earlier. That's the pendulum governor, and how nicely it picks the blade and misses when it's getting up to speed. Also, this is one of the oilers that John mentioned in operation. That's the oiler that lubricates the slide valve. You might want to take note of the water funnel here, where the water comes into the cylinder, the water jacket, and discharges out through the unique intricately cast funnel into the water jacket. This oiler here is the one that lubricates both the wrist pin and the cylinder. And here you'll note the nicely refinished and restored spur and bevel gears that was mentioned earlier, and how smoothly the engine runs as well. John Rex deserves a lot of credit for a job well done.
Our next engine is an 1893 design of Schleicher-Schum. Nate, the ones we've looked at so far were designed to run on city illuminating gas, which
This
was...
one's on gasoline.
That's right.
Right.
Illuminating gas was available throughout Europe, but in America only in the big cities, and we had more availability of petroleum products. So in this country, there was a demand for a gasoline engine, and the slide valve just didn't work very well when you mixed gasoline with the lubricating oil. So it was necessary to find some other ignition source and to go to a poppet valve on the intake, which we have here.
So now we're from a slide valve to a poppet valve type operation for. Okay.
Exactly, and this particular engine has electric ignition. It's an early type of make and break igniter, which is operated from a fast rise cam here, and actually has no hammer brake action to it like later igniters. It didn't really work very well. It was very hard to start. An alternative was to fire the charge with a hot tube, and some other designers were doing that at this time. Otto himself built an engine very like this in 1885. He developed electric ignition at that time and had a magneto to fire it. But the American Schleicher-Schum company lagged behind a little bit and didn't come to a gasoline engine until this model, which is about 1893. We think this engine was built in 94. And this particular model of the Otto was built for only a couple of years and was replaced by the better-known Columbian style, which was shown at the Columbian Exposition of 1893 and really got into production in 1894. This particular engine belongs to Roger Kriebel. It came out of a flour mill in northern Maryland. It's 17 horsepower. You see it has two flywheels, but that's more a function of the size of the engine being larger than the ones we've looked at before. Some of the slide valve engines of this size also had two flywheels. It has the spur and bevel side shaft drive yet. And it has the trunk piston. Now there was a slide valve version of the Schleicher-Schum, which was built almost on this frame and had the spur and bevel side shaft drive that had a crosshead.
This engine also has the same belt-driven oiler for the wrist pin and the piston lubrication.
Right there, yes. Actually, a little friction gear reduction there, like your engine had. They went back to the flyball governor for some reason on this model. It controls a PEC blade and operates a valve right in here, which admits the gasoline. The gasoline is simply admitted to the intake pipe. There is no venturi or nozzle or anything of that sort. There's a little bit of an ejector action because of the diameter of the valve stem there. It acts as a pump when the valve is opened, and then the fuel runs in by gravity once the valve is open. That's opened only when the governor decides that the engine should fire. It has an early version of a battery saver here. The battery is, or the ignition circuit is interrupted both when the engine goes too fast and when it goes too slow, so that you can't stop with the igniter shut and run down your battery when you're not looking. This will be running. It's Roger isn't here yet, so it will be running probably tomorrow. Well, let's go on here, Nate, to the next one.
This is an inverted vertical Schleicher-Schum with the Otto name on it. What year would you say this one is, John?
Well, this one was probably built about 1876. The design is a couple years earlier than that. But this model filled the need for an engine that would fit into limited space. The smaller sizes were built this way. It's what we call an inverted engine because the cylinder's on the bottom and the crank on the top, while our modern vertical engines are just turned over from that. But this design put the fire down near the floor where it belonged.
Mm-hmm. It also carries the same lubrication type system.
That's in here.
Also, it has basically the same pendulum system for governing as on the electric engine we saw a few minutes ago.
Looks like exactly the same parts to me, Nate.
Mm-hmm.
It has a poppet exhaust valve over in this area with a flat spring to hold the valve shut. The cam is built right into the disc that forms the crank to drive the slide valve.
There's the same typical burner type assembly for ignition.
Exactly.
And you might want to take note of the slide valves on the frame here, what they look like inside.
This is the cover, this piece right here. The chimney goes in that hole, and the ignition flame passes up through here. This is a groove through which the burner in the slide is fed fuel to keep it going. And over here, these are the intake ports. Spare covers and slides were furnished with every engine. If you had a problem, forgot to lubricate it or got it too hot, and scored your slide, you could put the spare parts in and return the originals to the factory, and they would refinish them and send them back, hopefully before you screwed up the next set. This is the slide. Yeah. Intake ports here. The fuel comes in through those little holes. That's the ignition port. This port simply gets gas from the gas valve there out into the cover so that it can come back through these little holes. That's always open.
It looks like they did some type of a restoration there at one time.
Yes, possibly so. That's the little hole that mates with this groove here to keep the fire burning.
Very interesting. How many of these do you suppose were made?
I don't really know. They're not as common as the horizontals, certainly. One other does exist.
That's a fairly heavy flywheel and cross section, isn't it? What would you say that is? 1.5, 2 horsepower?
No more than that. It's only a 4-inch bore in that great big cylinder. It has a 9-inch stroke. Nate, we saw the transition from slide valve to poppet valve in the horizontal Schleicher-Schums. Now this one is a vertical Schleicher-Schum, and we see the transition here to the poppet valve compared to the last one we looked at.
Still with the pendulum governor.
Yes. Well, this engine again runs on gasoline, which was available here in the United States, about wherever you wanted it. Has hot tube instead of electric ignition. Has rather an unusual fuel valve over here, which is controlled by the pendulum governor.
Oh boy, that's a long reach for that pendulum, isn't it?
When that thing decides to fire, it pulls this whole block up and works the fuel valve twice through that lever there.
Is this the only engine you've seen with that designed fuel valve mechanism?
I believe it is. This one belongs to Jim Withers from out at the Rolog show, and he's here today. Jim?
Hello, John. How are you?
Nice engine, Jim.
We like the auto engines in particular, and the family shows auto engines, and it's a hobby, but sometimes you wonder if it just isn't a way of life with us. This engine come from Plainwell, Michigan. A man named Bruce Gates had found it, and we bought it from him. It had been on site in a basement of an estate there in Michigan.
Pumped water?
It pumped water. We had some time to restore it, but it's been fun, and it runs quite well. We're happy with it.
Are we going to see it run today sometime, Jim?
Yes, we'll start it up.
Okay. John, this is kind of an unusual fuel system when you watch it work, the way that governor controls that latch and administers the fuel to the cylinder on the demand.
Seems to work pretty well, Nate.
Yes, it does. There must be some kind of a poppet valve underneath there that we can't see from here that gets opened on the intake stroke. I can hear it working.
I believe it works crosswise from right back in here, Nate.
Huh? Quite obviously, it's got a gravity feed system.
You get a little bit of displacement from these fuel valves because of the stem diameter. I think what they were trying to do was get that to pump twice.
Oh.
It strokes that valve twice each time that it tries to emit fuel.
Have you seen that on other auto engines?
No, I haven't.
I mean, pumping the fuel valve twice.
No. Interesting valve gear here, too. It doesn't have any cams at all. Just an eccentric and a kind of a bumper, I guess you'd call it there.
I don't know that I've ever seen a pendulum with this long a reach or finger, if you please. Have you?
No.
like pretty much a standard auto valve there, doesn't it? The fuel valve?
Uh-huh.
What do we got up here for eccentric and timing gears? And same lubrication system?
One pin for the cylinder and one for, well, not the slide. I guess those are both for the cylinder, aren't they?
It seems like they get down one pipe.
Yeah.
Here's an interesting addition I haven't seen before. There's an oil level indicator gauge.
These have such a teensy little piston in them, Nate.
That doesn't look as big as the other inverted auto, does it?
It's the same. We measured them last night.
Oh.
But you can see how that cylinder's tapered. The cylinder end looks like it's a big bore,
Yeah.
but the piston's about an inch smaller in diameter where it comes out. That probably is necessary for rod clearance.
Does this casting look similar enough so that it could have been at one time either used as a slide valve engine or a poppet valve engine?
No, I think it's different around the bottom. The crankshaft and flywheel are identical, and the top part of the frame is much the same.
What do you suppose this extension is here of the yoke?
I have no idea.
That's got some interesting early oilers on it. Look at it, all matched nice. Original oilers. Like all the rest of the autos we've seen.
I'm sure it'll run all day there.
Well, Jim, we want to thank you for bringing this nice engine.
It's been a real pleasure.
I know Kevin is somewhere in the background. Where is he? Come on up here, Kevin. Kevin, we want to thank both you and your dad for bringing this engine. Give us the opportunity to see it. It's a very nice piece, and we enjoyed it very much. Runs nice, just like all the Withers autos do.
Thank you very much.
Thank you. Well, John, it looks like we're back to Crosley's again.
Yes, this is the English licensee of the auto patents. And this is one of the half-horse side crankers. We saw one of these briefly over in the powerhouse. This one belongs to Ron McVeigh, restored by Preston Foster. And it's a really nice runner.
Nice restoration also. Boy, they did a lot of work on the nice bright works on these engines, didn't they?
This particular model seems to have nicer finish in some ways than the bigger Crosleys. They took a little more pains with their later ones than they did with the real early ones.
So this was a special market or something that they wanted to introduce this stuff?
Well, possibly. But it's cute with the side crank and the vestiges of a crosshead.
It's kind of nice with the pulley in between the two mains.
Nice until you want to put your belt on it there.
Ah, good point.
If you had your choice, you could put the pulley outside the flywheel if you wanted, and that shaft there.
What do these normally run along at? 150, 180 RPM?
I believe they were all 180, from the smallest to the largest of the Crosleys. The slide slide valves don't work very well if you try to get up very much RPM. The ignition becomes unreliable. And that seems to be the reason that they didn't run the smaller ones any faster than they did.
That makes sense. Is this engine on hydrogen to both the cylinder and the slide?
Yes, it is. But the other half horse, we find that it's convenient to start on hydrogen at least. Once we have the engine warmed up and up to speed, we can switch over to propane, and that saves a little hydrogen. It's interesting that Crossley stayed with the flyball governor on their small engines, while Spike or Schum went to the Crossley patent pendulum governor.
Well, you got to admit the flyball governor is appealing to the eye. I couldn't imagine anybody back when these engines were in their heyday imagining 100 years later that people would be standing around in amazement watching them run in full enjoyment. It's sure a treat.
I wonder if any of them ran this nicely when they were actually in service.
I have to make the assumption they didn't.
I know from running one of these models that governor is very difficult to handle, because if the engine misses just once or twice, the peck blade goes underneath that die and it'll stop completely unless you catch it.
Has no way to recover, huh? Once it's under it?
It thinks it's going too slow, so it's going to stop with the gas valve open, so it just never opens the valve anymore. It goes right down.
Suppose that was a built-in safety feature?
Yes, but they overdid it. We have a bigger one over here. What's this, a 2-horse?
I would say, I think it is 2-horse.
Well, this is pretty similar to your 3.5, but a little bit later, I think, because it doesn't have the cast name from Crossley Brothers in there.
I think the cylinder is bolted on a little bit differently too, isn't it?
Yeah, yours had the continuous flanges around here, while this one's got the 3 lugs.
And there's one oiler rather than 2. One of the things I noticed about Crossley, they all had this air intake filtering system.
That's a silencer. It has a series of horizontal plates in there with staggered holes. And every so often that fills up with fuel and you get a great big cloud backfire. So they're made very heavy so they won't blow up. Slide valve engines, you'll see this strange looking plug on top of the cylinder, and that was intended to put an indicator, like you could make an indicator card for a steam engine.
To test the output performance of the engine?
Make sure they had the timing right for the fuel that it was using.
There isn't a great deal of options in timing on these, is there, other than changing the tooth on the camshaft or something?
You would have to change the ports themselves, because the crank is integral with the side shaft, and the timing gears are very coarse and can't be rotated on the shaft. So if you want to make any adjustment for a specific location, like if the fuel was different here or there, it would require change to the actual porting in the valve.
I see. Interesting. You suppose they offered them with those various slide valve options.
Well, possibly, but not to my knowledge. They seem to do everything they could to make the engine impossible for the user to get out of adjustment. Most things are quite fixed.
A fuel accumulator that stores a sufficient amount of fuel in it, 2 or 3 revolutions or strikes at a time to get up to speed or under heavy loads.
That stores enough so the engine has something to draw from, and it also isolates your gas lines from the pulsation of the engine. So lots of places would have gas lights on the same line as their engine, and you wouldn't want to see the flame flicker every time the engine took a suck.
Now we got another slide valve Crosley here.
This is Crosley's version of the inverted. One of the earlier ones out. This was about an 1883 design. You notice this one's got a bigger piston too. I think this is about 3 times the power of the others we were looking at. This is another of Ron McVeigh's engines. All 3 of these Crosleys belong to Ron. Kindly brought up by Christopher Eby.
The intake mechanism is a little bit different on this than what we've seen in some of the others. A little bit different pendulum design.
Yes.
That looks like a little heavier engine with the auto inverted vehicles we've seen it then.
Rather strange exhaust valve setup over there too, Nate. See, that's kind of a sector-shaped piece comes right out of the side of the cylinder to withdraw the valve.
Did they put that on any other engines other than these slide valves?
I don't believe so.
That must have an oil as soon as the others we've seen, but how that one works. Well, that's a little bit different, isn't it, John?
One of those others had double gears.
That's interesting. That oil's on both sides. You notice that? On one side of the slot, it picks up the oil for the cylinder, and on this side of the slot, it picks the oil up for the slide.
You notice the extremely long stroke to the fuel valve on that, Nate. This valve here must have pretty near an inch stroke. I think that's necessary to make the decision point at the right time for the pendulum governor.
I see. It seems to work extremely well.
I've run this engine at a few shows, and it's always been very pleasant.
You can see that here.
Now this next one is a little different, Nate. This is not really a slide valve engine. It's a rotary valve engine.
Uh-huh. I don't think I've ever seen one of these before.
Well, I've never had one to play with, and I guess we're going to have to play with this before the show's over and find out about it. It has a hot tube,
Okay.
and it runs on gas, and it has no poppet valves at all. It has like a rotary plug in here,
I see.
and that controls both the intake and the exhaust. Just like a quarter-turn valve, only it turns all the time.
So what does it do? Communicate with each passive respectively as the functions are required?
I guess it must. It must have a port in here from the cylinder, and then apparently ports that go out to the intake silencer and to the exhaust silencer over there.
Well, where would this fit into the technology between the slide valve and the poppet valve?
Well, I'd say it's an offshoot.
Oh.
It was an early 90s design. There were some larger English engines that used rotary valves designed by a man named Butler.
Successfully used them?
Well, he built them for several years and never made a whole lot of money out of them. I don't think any of them exist yet. It does have one little poppet valve in here to control the gas. There's a pendulum governor that has a special eccentric here to drive it, and it's working back through a PEC blade, and right in here apparently there's a little poppet type gas valve, and everything else is done by the rotary valve. I think you got him, Nate. Finally got the tube hot there and got the governor set right.
It's kind of an interesting engine.
It has to be very early 90s, don't you think?
I would certainly think so, yeah. Do you know of another one?
No, I don't. I don't know very much about the Wayman engines. I think they were always low production and pretty rare. I know that this particular one was brought from England about 30 years ago by Dennis McCormick.
Oh, yeah.
And it's now owned by Ray Ellison of Kerrville, Texas.
How would you explain this governing function here? Is that a Scotch yoke type of motion?
Well, almost. At least it keeps a continuous motion to the pendulum, so it has an excitation force at the right time. I was wondering there if you were going the right direction, though, moving that ball up to make it go slower, but apparently it worked that way.
Seems to work very well now.
Beautiful big brass main bearings in that engine.
Look at the timing gears.
Very coarse.
Very large.
Beautiful big cylinder setting way up off the frame there and machined at the crank end.
It's kind of unusual to see a shelf-mounted cylinder with only 2 bolts in it too, isn't it?
They're pretty big bolts, though.
Yeah.
I think it's just a beautiful engine with that great big flywheel and a great big pulley on it.
What horsepower do you suppose that is? 5?
Yeah, 5 or 6.
Seen oilers designed like this before, John?
No, not just like that, Nate. I think they must have made those themselves. Don't see any names on them.
If someone found some of those in the flea market, he decided he might find an engine. Look what we have in here. Pretty much standard.
This is one of the earliest engines with a poppet intake we've seen that had a power-operated intake.
That's right. Yeah, that mechanism right in here surely is different, isn't it? They got wing nuts for take-ups on the valve springs.
Apparently, it doesn't counterweight it at all.
Well, John, I guess we got a nice collection of White Middletons here today. I see 3. Here's a nice old one brought in from Kentucky by Terry Tanner. Terry, nice engine.
Glad to meet you, mate.
Thank you for bringing it up for us.
Oh, glad to do
Can
it.
you tell us a little bit about it?
Well, I've owned it about 10 years, and it's been torn apart for most of those 10 years up till recently. It turned up at an engine show in North Carolina. Had just come off an estate there. And
Pump water?
I believe it was, yeah. It had been bought by a local fella, and he brought it to the auction to sell. And I bought it from the fella who bought it at the auction.
Okay. Well, that was certainly a lucky find.
Oh, yeah.
Can you tell us anything about the date?
It's stamped. It was built 6/22 of 95. And I'm not sure the horsepower. It's right around 4. It's a pretty good engine. The cylinder was real bad, need to be sleeved, but mechanically, other than that, it's real good shape.
That's kind of a big engine for 4 horsepower when you think of it today, isn't it?
Oh, yeah, yeah.
Okay, can you tell us something about the unique features on it?
Well, the unique feature on this one, I think, is the igniter in this casting here where the hot tube usually goes. And it's gasoline, which was unique for that early of an engine, with a kind of an injector pump there that injects the fuel and then it just lays there until it needs it.
Have you ever had it running?
No, I haven't. I just did get it together in time to bring it up here. We may start it later.
Okay.
I don't know.
Okay. This I take it over here is a water funnel?
Yeah, like on the others, a return funnel. It also has this extra valve here that they discontinued later, so the exhaust can't blow back.
That's kind of a little bit different than the other engines. As I look at it, the other engines with that supplementary valve has a port through the side of the water hopper.
Yeah, I was looking at that back here, yeah.
About in the same system as the ports have.
Yeah. But it was complete except for the top on the oiler, which the piston trip oiler. But
we shouldn't have any trouble.
No, I should be able to come up with that, a coffee pot lid or something.
Okay, is that the only White and Middleton that you folks have seen in that?
Yeah.
Very good. Can you turn it over for us?
Well,
can
yeah.
See it turn over?
Oh.
You got a nice governor. Oh, very good. 723. Okay, Terry. Thank you very much.
Yeah, thank you.
So where's my partner, John Rex? Here's another White and Middleton. Quite obviously, the owner must have gone fishing. Where's Dick Leverall? Oh,
Here he comes.
oh, there he is. Dick, nice engine.
Hi, Nathan.
Thanks for bringing it.
Thank you very much.
Can you tell us anything about your engine?
Well, it's a 20-horse White Middleton. Electric lighting flywheels. Got the oversized
yeah.
flywheels.
That's pretty interesting.
Yeah. And, of course, it's a little later design than the one you just looked at.
Okay.
But, still has the same basic features.
Trust it probably runs as nice. We going to get to see this run today or what?
Well, I think I could probably start it up for you.
Okay. Tell us a little bit about that unique oiler.
Well,
How does that work?
This is a piston trip oiler. As the piston travels back in the cylinder, there's a rod that protrudes down into the cylinder, and the edge of the piston tickles it, and it just lifts it up. There's the little rod here that it lifts up.
Pick it right up so I can see it.
Now, when I pick this up, you'll notice that the oil will come out of here.
Okay.
Basically, it's the same thing.
Oh, there's a face valve on the inside of that, huh?
That's correct.
Okay.
That's what lets it down through.
Very nice.
Yep. That's kind of a little bit different.
Wow.
Yep.
Good.
It's fitted for electric and hot tube.
Have you ever run it on a hot tube?
I haven't as yet. It's a pretty new thing that I just put on there, but I'm sure it would probably run.
Where did this come from?
This came from a good friend of mine in Connecticut.
Boy, I'd like to have a friend like that.
I'm glad I have one.
Isn't this the engine that last saw service in Concord, New Hampshire during the 38 hurricane?
That's correct. It ran a 32-volt generator.
Right.
And for the Concord telephone, and
Okay.
I believe it was the last time it ran was in the 38 hurricane.
Very good. A little history with that engine.
Sure is.
Wow. Maybe we could get you to start it for us.
Sure, I'd be glad to.
Would you? Thank you.
Open up the compression release over here. A little easier to turn it over. Put our gas where we think it'll start the best.
You have to retard the spark on those.
This one I don't have to.
Oh.
There's a provisions to do it, but seems to start pretty good in the front position.
Excellent.
No.
Boy, what a nice big engine.
There we go.
That sounded positive.
Yep.
Ah.
I think we have it now.
Ah. We're ready to generate electricity again.
Lights are back on.
Show us how that oiler works now. Let's take a good look at that.
On this oiler here, what we do is
Show us how that works.
this is a lock nut, so it keeps your adjustment right.
Okay.
So you don't go down too far, and that little pin that we showed you up in here would protrude down too far. And
Well, that's a drip coming off, huh?
yeah, you just got to screw it down so it starts dripping.
There it is.
Okay, now we got to back it up. That's a little too much oil. I guess we want like about 6 drops a minute, I guess would be safe. And I'll lock this here so it won't move. And that's pretty much it on the oiler. And the other oilers are just your basic flip type oilers.
What a nice machine.
Thank you.
Dick, thank you.
Pleasure to be here.
Well, hello, Nate.
Hi, John.
How are you doing?
Co-chairman.
I guess this is your
Yeah.
masterpiece here. I see it's a white Middleton, and it's in superb original paint. Tell me a little about it. Where did you find it?
This engine came out of a kind of a sheet metal shop. It ran rollers and shears and shaping machines for sheet metal shearing and so forth. It came out of Worcester, Massachusetts. It was bought and put in by the present owner's great-grandfather, who put it in the mill around 1895-96. It was a new engine and a new installation at that time. And we were fortunate to find it, and then fortunate to get it out. It was quite a task to do that. But this turns out to be one of the early White and Middletons with a single valve or a single cam on the cam wheel here that works both the exhaust valve and the gas valve. And this engine has a supplementary valve over here that closes the port in the cylinder when the exhaust valve is wide open to allow the gas valve to open. It's the earlier designed engine, and all the parts are there, and it's a completely as original engine.
Now, I see it runs on hot tube only. There's no electric ignition on this one.
That's right. It was the earlier version of that engine, and they were strictly hot tube.
How long ago did you get it?
Well, I got it, I think it was in November of last year or October of last year, and we worked on it through the winter steady and got it running specifically for this show.
Gee, that's very unusual to find something this nice and this original in today's environment. And that's
Very true.
remarkable that it's such a fine engine and it's a recent find.
Yeah, it's a very nice engine. I'm very happy to have it, and the thing that is equally as rewarding is it runs just as nice as it looks.
Right. I like the Oilers you've got on it. They're beautiful.
Thank you.
Yes. Does it run?
Oh, absolutely.
Well,
absolutely.
You can see it run here. And
okay, well, I've gone a little bit in advance just to
and warmed
simplify
up the hot
things.
tube.
I have the hot tube burning already, which you can see here. We can give you a little fire for effect.
Yeah.
And I believe the hot tube will be warm enough.
It's a good way to get your nose burned.
Oh boy. And we've got the latch underneath the throttle mechanism here so that it'll punch the gas valve. And of particular interest when this engine runs, you'll see a quick puff of this cam here, which means that to come up on the high cam and open the gas valve simultaneously while the exhaust valve is open, and then this valve is shut so that the gas don't run out the port
Okay, that's
into
very
the
unusual.
atmosphere.
Well, shall we see it go here?
Well, I hope so.
What's the purpose of this post here?
So I believe that we can define what that is now. The later models of these engines were either outfitted with igniter or a combination of hot tube and igniter, and it was an eccentric in here that gave a throw across the top of the engine for an igniter push rod, and the igniter would have sat here. And as you look at this small engine over here that we saw before, they had an extension block on it with the igniter in it, and the hot tube sat on that. So they could have been outfitted for a combination of either electrical ignition or hot tube ignition. This particular engine, as we've got it, was outfitted only with the hot tube, but it did have the post, which means they did think, or
They
perhaps
had the option.
Exactly.
Right, of putting
and not
an
only that,
igniter on it.
the lugs are here on the governor stand to support that eccentric.
Right. Well, we'll see how well it runs.
I mean, how well it was restored.
Yes.
This little mechanism over here is a compression relief mechanism, and it goes directly, it's a boss that goes directly through the passage here for the exhaust and goes into the compression chamber. And it's nothing more than a valve.
Would you like me to close that when it starts? Or?
That would be nice,
Okay.
making the assumption it starts.
And give it a try here.
And as it comes up to speed, you'll notice when the governor stand lifts up, that little wedge that holds the arm for the gas valve will fall away.
That little crutch
So then it's
drops
totally
out.
controlled by the governor.
Well, it's a good starter.
And again, you go back and look at this mechanism here. That's a normal coaster. Now, when it goes in, penetrates excessively, that opens the gas valve, and correspondingly, you can see it open the valve over here. And at the same time, again, that valve is shut.
Yeah, that's very unusual. We don't see that much on too many other engines.
It's just a nice big old Eastern Seaboard engine. And this again,
Tripped the oiler, similar to the other one that we just saw. That adjustment, I guess, is setting the drip rate so that it's suitable for this engine.
boy, that thing is really vicious. drips out of the oiler proper here, gets picked up in this trough and runs around, and there's a flat on this threaded connection here that runs directly to the cylinder.
Well, that's very good, Nate. Nice job. Nice engine.
Thank you, John.
Okay, our next engine is an Abenaki, and I have Dick Oliver from Massachusetts here.
Holyoke, Mass.
And he's going to show us the Abenaki. Abenakis were made in Vermont, and
Yes, this is an early example of a 5-horse Abenaki. They were built in Westminster Station, Vermont. This was a popular size used on the farm for general belt work, pumping water, cutting wood, grinding feed. They were built from the early 1890s to approximately 1912 or 15. As you can see, they were somewhat mechanically complicated. It was kind of a crime to sell one of these to a farmer, a man who had worked with horses. As they're very temperamental. You get them out of adjustment a little bit, and they plain don't run. This is as I say, an early version. It is self-contained oiling. It has a splash system oiler, a white spark ignition, and side shaft construction with the unique water hoppers that are on it. They were quite unique to the engine. As far as cooling went, they weren't seen on, I don't believe, any other engine. The larger the engine size, the more fins or tanks you had on the engine. An 8-horsepower engine had 4 of these. A 15-horsepower engine would have had 6.
are these what they call fin tanks?
Fin cool, yes, fin tanks. You didn't need a lot of water to cool the engine because of the surface, the area that the water covered, so that you got by with a minimal amount of water to take care of the engine as compared to a hopper-cooled engine or a tank-cooled engine of the same size.
Yeah, that is a lot of surface area for such a small amount of water.
Yes, absolutely. And a unique feature to this engine.
I would imagine the air circulating near the flywheels, that additional little breeze helps cooling.
Helps to cool it. Yeah, there is no doubt about it.
Now, I understand that Abenakis are sort of unique in that the governor, is this the governor that's called a dog bone style governor?
This style, yes, used what they call the dog bone governor.
And that's what we're looking at here
What
then.
you're watching there spinning on the side shaft, centrifugal force would move that in and out and hit the governor detent to trip the engine off so it would fire often enough to keep it at a speed. You can see that working now.
Now, I see a plunger moving that's right in this area here.
Yeah.
I assume that's the fuel pump?
The plunger controls the fuel pump. The engine basically has what they call, it would actually be a form of fuel injection. The pump moves a charge of fuel up to an intake port and sprays it at the proper time for the engine to fire.
Okay.
It's an early form of fuel injection.
Okay, and I see that this is the plunger here, but the pump itself is underneath the cam there.
The plunger up here is to prime the engine for starting. That's why that is located
with
up
the
above.
T-handle on it, so you could pump it up and down.
And, of course, that also works the wipe spark ignition, the trip mechanism for the wipe spark. In other words, you watch it while it coasts, not too much, and then all of a sudden there's a lot of action. It takes a while to figure it out.
Right. Yeah, this is the wipe spark ignition wheel here. This is on the other end of this, which is in the cylinder, and it's a wheel, a star wheel, that wipes against the spoke, and the spoke comes from the igniter mechanism here down inside the cylinder, and the star wheel on the end of this shaft wipes against the end of the spoke. Every time that this lever pulls and rotates the wheel 1 notch, the wheel edge wipes against the end of the spoke and creates a spark for the ignition. And it's a very unique part of Abenaki. This is a beautiful engine, and it's extremely quiet running.
It certainly is, yes. It's a good show engine. It's somewhat mechanically complicated, but it's nice. It's nice to take to a show and show off. If you notice the intake and exhaust valve, another feature is this uses a flat leaf spring rather than a coil spring for the intake and exhaust valve. The intake valve being here, and on the opposite side of the exhaust valve, they use the flat leaf spring rather than more conventional coil spring. Another feature not found on a lot of engines.
Well, yes, I guess that makes these so desirable, I guess.
Absolutely.
Are there any more unusual features about the engine?
Well, of course, the side shaft construction, which is nice and found on earlier engines. The wipe spark.
Anything unusual about the gas tank or the situation that it is in there?
The tank is located between the Z irons.
Right.
These irons are unique to this engine. If you notice, they're constructed flat, vertical, flat again, what they call a Z iron. They were used across the board on Ebanax. But not seen on any other engines. It was another feature that the engine incorporated. I think other than that,
boy, it's a beautiful piece.
It is a nice engine, and it's a nice running engine.
Certainly, thank you for showing it to us, Dick. And
I'm glad to be out here for the Centennial.
Yes, that's a super engine, and it's interesting to see why these are such desirable engines.
Yeah.
So thank you for showing it to us.
Thank you, John.
Great engine. Okay, I'm here with Bill Santos, who's all the way in from California. Bill has brought us 2 engines in from California, and welcome to Coolspring Power Museum, Bill.
Thank you, thank you.
I see you have a Bishop, which is a very early design. Bill is unique in that he's actually built these engines, built the patterns himself, and I'll let Bill tell us about them. We'll do the Bishop first, and then we'll do another engine that he's built later.
The Bishop, there are about 6 of them in the world, and I knew I couldn't own one unless I built it. And so I measured one in a Ford museum, did some measurements in one in Edinburgh, Scotland, came home and spent the whole summer making wooden patterns. Had it casted, did the machine work on it, spent some time making it work after it was all completed.
Boy, it's a beautiful job. Now, this is a non-compressing engine rather than a compressing engine, that's right?
That's right, atmospheric engine.
And it uses flame ignition.
Flame ignition.
What sort of fuel are you running it on?
We're burning acetylene on it.
Okay, acetylene gas. Why didn't you run it on propane or some of the more easy-to-get fuels?
Yeah, propane was pretty unstable. And 4 weeks, it ran 20 minutes the way it should run on propane.
So it was just a very finicky fuel, hard to work with, and you find acetylene is an easier fuel, is that right?
Much easier, yes. Well, I think the acetylene ignites under a larger scale of conditions.
It's a beautiful reproduction, and you've done a wonderful job on it, and I guess it's full scale.
Full scale. And the interesting part is, 1872 engine, and it was casted in a foundry in California that was 1873, water-powered.
Okay, so you used probably the Knight foundry up in the Placerville area.
Sutter Creek area, yeah, right.
Okay. Well, maybe you could show us how it works here. I see that the ignition flame does run on propane, as I see a propane tank on the left side there, but the main charge is acetylene.
Right.
Well, maybe you can run it for us.
Okay. We're just igniting this is the ignition flame here.
Is it?
And we'll give her a turn or two and turn on the fuel, main fuel. Takes a second for it to get there. Takes a little while for it to get warmed up, and it settles down. And
yes, this is a very unique engine, Bill. I can see why you wanted to own one. I guess in the normal operation, that trap door would be closed. But for show purposes, you're leaving it open, I guess.
Yeah. This machine is rated at a 2-man power, which is about a third of horsepower at 110 RPM.
A little bit finicky until it gets warmed up.
Turn that valve down just a little bit.
I'll turn the valve down
just a little bit. Yeah, there you go. This valve is the intake and exhaust valve. Air comes in there, fuel here. When the valve is up, it's intake, and when the valve is down, it exhausts out the bottom.
And I understand in the flame ignition system, there's a small flapper valve that just is like a penny or a dime hanging behind this port on the inside.
Right.
As the piston comes up, it sucks that flapper open, and flame sucks in, which fires the charge.
Yeah,
right?
right.
Yes, it's a very nice engine, Bill. Wonderful reproduction. Well, I think that shows us your Bishop. Bill's got another engine over here, which we'll show you next. And that's another engine that he built.
I would like to say that in the design of this engine, his advertisement said very little floor space, and that was due to his connection with the cross arm and the connecting rod. Was air cooled, required no lubrication because the coal gas put out a residue which lubricated.
I guess the soot and the slight oil residue from coal gas was sufficient to lubricate the cylinder.
Yeah, but it was as far as self-contained unit, it was way ahead of its time.
It sure was. I seem to recall reading something about one of these ran for 30 or 40 days continually without stopping.
That would be
on coal gas.
On coal gas, yeah.
Well, that's a very good engine, Bill, and you did a nice job on it. I'm here with Bill Santos again from California. Bill has another reproduction here that he'd like to show us. It's the cogwheel. The engine was invented initially in 1857. Bill's reproduction was made just recently in the last few years. And why did they call it a cogwheel, and what can you tell us about it, Bill?
Well, the young gentleman that made this back in that period of time was fooling with the gas that they had to make a chicken brooder, and the chicken brooder blew up and almost killed him. So he thought that if the gas had that much power, he could do something with it, and so he built an engine. And the only thing he could find for a flywheel was a gear out of a mine, and of course in England they call all gears cogs.
So hence the name cogwheel engine.
Cogwheel engine. And he later built engines out of iron that ran a 10-inch table saw for his dad. Lasted many years.
Were these ever commercially produced?
No, this was like the one of a kind, and possibly the first two-cycle engine ever made.
I see. Okay. Well, it certainly is unique. It looks like basically it's a wooden box with a crankshaft and a crank rod, or connecting rod, going down into the box. Maybe we can see a little more of the features down in there and see where that goes.
The piston and the cylinder are in the box, and the box is a radiator, which is filled with water around the cylinder for cooling.
Well, there's no question about what it's water cooled, and you can certainly see how the cooling works.
And this also is a non-compression engine. It has all the components, though, of a modern-day engine. This first overhead cam engine. It has cams and has a poppet valve, and has a radiator and a cylinder. And
how did you get the information to come up with this design?
We got this information from his original drawings, and he left a dimension of 3.5-inch bore, and I scaled everything from that
scale drawing.
From the scale drawing to this is so close to the actual size of the engine he had.
Well, it's certainly unusual. Maybe we could see it run.
We'll see if we can start it up here.
I guess it is flame ignition now.
This is flame ignition also, yes.
Right.
What I did just there is light the ignition flame. This lever uncovers the hole right down here. Fuel and air go in at the bottom, and when this uncovers a hole, the flame is sucked in and ignites the charge that's in the cylinder. I think we need just a little more pressure.
Okay, we'll bring you up a bit here. That's about a couple degrees of turn. Let me know if you need more.
Just a little bit. Okay. I think I'll need a little bit more.
Want more yet?
Just a little bit. Yeah. Just the fact that he created something that would run
It's pretty remarkable, isn't
is
it?
remarkable, you know. It's the next step from the crank.
Is this what you would consider its normal operation about an
It
hour?
probably would go, it goes a little bit faster after it warms up.
Right, okay, but this is a typical startup, is that
Sure,
right?
sure.
Well, it certainly is an unusual engine. I bet it attracts a lot of attention at shows.
I like to say that it took 2 weeks to get the smile off my face when it first started running.
Yes, this is actually the most unusual engine I've ever seen.
It's a good attention getter.
Oh, she's going full speed
Sure.
now, right?
Picking up a little RPM.
Well, very nice engine, Bill. I'd like to thank you for bringing these all the way out from California.
Okay, thank you.
And it's a wonderful example of some fine workmanship, and we appreciate it, and the museum appreciates you bringing these out.
Well, I think that these original engineers, you know, really, you know, they really were
innovative and ahead of their time.
They were, right.
Okay, well,
right.
thank you, Bill.
Okay.
Okay, I'm here with Raymond Scholl from Sugar Grove, North Carolina. Welcome to Coolspring.
Thank you. It's good to be here.
He's brought a Springfield engine. It's a beautiful restoration and a nice example. And why don't you tell us a little bit about it, Raymond?
Well, the engine came out of Ohio near Buckeye Lake and had been stored in a edge of a corn crib for about 50 years and just needed an awful lot of work.
Okay, what are some of the features of it? Maybe we could go around to the front and you could point out some of the unusual features of the Springfield. I see it's got an inclined upward side shaft on it, and it looks complicated.
Yes, the valve train is operated from the inclined side shaft. You have a front shaft that's very similar to a camshaft in an automobile engine today. And you have your standard valve on this side for exhaust, worked off the cam. You have your intake valve, which is also power operated off of a cam. You have a third valve inside the carburetor to control the speed of the engine. As long as this governor keeps this back, then it can't take in any fuel. And when the speed drops down, this comes in on the inside and it pushes this down, opens this valve, and allows the charge to come in, and then next time it's compressed, it will fire. The igniter is never shut off. It continues to trip as the engine rolls around. There's another feature on this engine that doesn't have anything to do with the engine firing properly, but it does keep the engine from being destroyed if you roll the engine backwards. It has if I can roll the
sort of flip clutch
yes.
on it?
As I'm rolling the engine backwards, you'll notice it does not trip the igniter, and it has a little pin that jumps out.
Oh, yes.
Okay.
Right, keep on doing it. Oh, yeah.
All right. Now, when you roll the engine the correct direction,
then it will pull that pin
picks up the cam.
and then it will let it actuate the igniter. As you can see, this part right here would catch this down here, and then it would shell the teeth off the gears.
Yes, this is very unusual with the side shaft originating back here with the spiral gear, coming uphill, then turning 90 degrees, which I assume is bevel gears, and then progresses across the front of the engine.
Okay.
Very unusual and unique to the Type A Springfield.
This is one of the gears that came off of the engine. This was the small gear on the upward end of the inclined shaft. As you can see, they broke some teeth, and they drilled and tapped and then put in little old screws or bolts and then filed it back out. So we chose not to try to reuse that gear, but saved it. And you can see with the rust pitting, this section is what was meshed for about 50 years, and what little bit of oil was there preserved those three teeth pretty nicely, and then the rest of it just left pitted.
Just very nice. Maybe we could see it run.
Can I bring the son in to start it?
Absolutely.
Take just a second.
Yes, this is a very nice example of a very small Springfield, a very rare and unusual engine. And Raymond will be right back there with his starter.
My son Jody is here at the show with us, and my nephew Travis, and Jody's my right-hand man. He's 15 years old and much larger than what I am.
Be the Springfield starter.
Yes, so he's going to be the Springfield starter. Okay, son.
We got the gas on.
Be sure and check your ignition there to make sure that you got spark.
Mixture must have been a bit rich on the starting, and so he had to lean it out a bit, I guess, to get it started.
Of course, the engine is a natural gas engine, and because of having no natural gas at most of your shows, we chose to switch it over to propane, and so it's quite easy to flood.
Yes, well, it's certainly a nice example.
Thank you.
We appreciate your bringing it to the museum all the way from
Thank you. We appreciate you all inviting us to come up.
Stopped there, but it made it on through. For bringing the engine all the way from North Carolina.
Thank you. Glad to be here.
To see such a fine engine.
Thank you.
Thank you. Okay, we have a very interesting engine here that was brought in by Tom Stockton from Ann Arbor, Michigan, and he just brought it in last night. And it's the only example that I've ever seen. And can you tell us a little bit about this engine, Tom?
Yeah, this is what's commonly known as a Bischoff type engine, which is a French patent. They were first built in Paris in small numbers. They were built in large numbers in England, and also They were built by Buss and Sombart in Magdeburg, Germany. The Sombart name apparently came from Germany, and we assume that Sombart bought out the rights, the drawings, and so on for the company in Germany. This engine runs on hydrogen. It runs on the Lenore thermodynamic cycle, which is basically two-cycle, has no compression, very inefficient, but very simple and very easy to operate.
About what date would you say it was?
This was built about 1884, okay? And it's the only American-made engine that we're aware of that exists. These were made in 5 sizes, number 1 through 5. This is a number 5, which is rated at 3 horsepower, okay? Some of these were rated in manpower, okay?
Okay, for example, the model that we saw yesterday, or the reproduction, would be a manpower size.
Yeah.
Well, it's a very interesting engine. Maybe we could start it up here.
Okay, now of course we're running on hydrogen, and the first thing to do is to ignite.
Okay, I see it had a small flame on it, so
it has a flame igniter with a vertical and horizontal jet. In case of one flame blows out, the other one relights it. And then, John, if you can crank it through,
I'll go around to this other side here.
I'll open the gas regulator valve.
You tell me when you're ready here, Tom.
I'm ready. Go ahead.
See, it's an easy starter.
Some of the unique features of this engine, it has a spool valve, which is something like a steam locomotive valve. This is the air inlet, which is a perforated plate with a rubber sheet behind it, and this is a check valve for the fuel inlet. Now the fuel comes in here, comes out the bottom and goes over to the igniter, and this is the main fuel line, which the exhaust and admission is controlled by that valve. Now you notice that flapping sound is when the engine fires. This communicates, and that just slaps that rubber diaphragm shut. Okay.
What sort of RPM do you think it runs at?
This runs at 80 RPM.
Okay. Extremely low power.
And very, very inefficient because there's no compression. But on the other hand, it was very simple, easy to operate, and very practical.
Quite popular before the 4-cycle engines were developed for small jobs.
In fact, Sombart and Buss in Germany built this type of engine because they couldn't get the auto patents. When the auto patents expired, they dropped making these and concentrated.
And went to the auto-style engine.
Yes, and then I think about that time, the American company bought their rights, their name, and so on.
Yeah, well, it's a terrific.
It's really a German design because Sombart in Germany designed all their own engines and made improvements. Like they added piston rings and things like that.
Well, it's certainly a good runner and an interesting piece, and it's the only one that I've ever seen.
Okay.
Made in Connecticut. I have seen a couple in England, the Andrews style.
Okay. This is supposed to be a rubber bag, but I can't get one.
Right. Oh, it's a very interesting engine here.
I think it's also good to say that these early engines were designed to run on illuminating gas. Illuminating gas has 1/8 the heating value per cubic foot of propane and 1/6 gasoline vapor. So propane or gasoline is too powerful for this.
So hydrogen is our nearest modern equivalent that's suitable for running the engine.
Yeah. The exhaust coming out of here is water vapor, so it's pollution-free.
That is one of the only combustion products.
Yeah. A little oxide of nitrogen. We'll talk about that.
Right. uses the little flapper valve down on the ignition port. That's just
Yeah, that's mainly to keep from blowing out the flame. It's just a small hole.
So that snaps the ignition port shut as it fires. That keeps the flame from shooting out and blowing out the pilot. It's a very quiet runner.
Yeah.
Extremely easy starter.
Oh, yeah. It's the best it's ever run. Yesterday it wasn't running as good.
We're getting a good look here at the ignition port. You can see the pilot flame there, and there's a little flapper valve that's between the pilot flame and the cylinder. And that flapper valve, which is not visible, is behind the hole. And that flaps shut every time the engine fires so that the flame doesn't shoot out through that hole and blow out the ignition flame.
Fuel pressure is about 1 pound per square inch, down from 2,000.
Right, okay. So, yeah, this has to run on very low pressure, obviously, which would be equivalent to what the old illuminating gas.
Yes, yeah.
Well, it certainly is a beautiful and a major contribution to the show here. So I'd like to thank you again, Tom.
Oh, I'm happy to do it, John.
To the show. It's a terrific exhibit.
Thank you. Okay.
A major contribution. Okay. Next, we have a Lenoir model engine owned by Fred Pritchard of Plymouth, New Hampshire. And Fred has made this model. Normally a model wouldn't qualify, but there are no examples of Lenoir. And so a model is a suitable example to show us how that works. Fred, welcome to Coolspring.
Thank you, John. Pleasure to be here.
Maybe you could tell us a little bit about this model and when it was made and how long it took you to make it and so on.
Well, the original start of this was in the spring of 1990 when I visited the London Science Museum and noticed their original Lenoir. Decided I would like to own one and measured the engine for a 1/3 scale model. This is true to the original Lenoir with jump spark ignition. It is a non-compressing double slide valve, double acting gas engine. The governor was added as per the American Lenoir. There are about 400 originals made, of which 2 survive, neither of which are in running condition. The engine was the first commercially produced internal combustion engine and was in production for about 10 years until superseded by Otto's engine. They were plagued by very high fuel consumption, a poor lubrication system, and a very small power output. The original engine, which has a 4-foot flywheel, had a power output of 1/2 horsepower. This model produces probably a 1/20th of a horsepower, just about enough to turn itself over.
Okay, I see that even though the American governor style is on it, that's the only deviation that you really took over the one in London. Right?
Yes, in terms of scale, flywheel size, bore stroke, and design, it is as close as you could humanly come to the London engine. Not being able to tear the London engine apart meant that the valve mechanism, the internal valve design, had to be...
You had a little bit of guessing, I guess.
A lot of guesswork and a lot of reading of original literature supplied by yourself. Thank you very much. The engine runs very well on hydrogen fuel, which we just started running on about 2 weeks ago.
I I see that the spark plugs, as they referred to today, which I can point out right here, this is one of them. In the original literature that I remember, sales literature refers to those as inflammators.
Inflammators.
Cause inflammation of the fuel, I guess.
Exactly.
And I remember that the literature required that if you had a problem with the engine, the first thing was to remove and clean the inflammators.
They recommended you keep 6 complete sets on hand at all times. Of course, the byproduct of the original town gas that this ran on was water, one of the byproducts. And of course, water shorts out spark plugs. And that was why all subsequent engines up until the turn of the century used hot tube or flame ignition, whatever, because they had so much trouble with the original spark plugs.
Maybe we could see the engine run, Fred. And,
well, we'll give it a try, John.
Okay.
We open the needle valve, give it a pull.
Gee, it's a tough starter.
It is a very tough starter.
That is amazing.
The original literature stated they were smooth, silent, and if you didn't know it was an internal combustion engine, you would think it was steam. And they have generally proven that point.
Yeah, certainly steam engine origin visible there.
Yes, very, very much so.
Many of the valves are designed.
The slight knocking sound heard is a function of the fuel being used. It's comparable to a diesel ignition knock.
Because of the speed at which the fuel burns?
Yes, exactly.
Detonates, I guess, right?
The hydrogen is much less than acetylene as fuel. The acetylene produces a very loud, pronounced knock in that it explodes rather than burning, where the hydrogen burns at a slower rate.
Or explodes.
Or explodes at a slower rate, exactly. One of the problems on the original, of course, was the lack of steady lubrication. The original builders were used to steam engine lubrication, which, of course, is very infrequent. And with the red-hot piston in there, it burned up the lubrication very quickly. And there is no way to constantly feed lubrication to it. The lubricator is a one-shot deal that...
Slow it down a little bit here.
This slide valve is the exhaust valve, which opens on both sides to allow the exhaust for the double acting on both sides of the piston to come out. This one is the intake valve, which allows gas on this side, air through the top. They meet on the top of the slide valve, go down the back side and into the ports on either end of the cylinder. Figuring out the configuration of this valve was the key to making the engine run, as none of the original literature illustrates the internal workings of that valve. So it was about 6 months of cut and try with plexiglass valves to watch the various motions inside to see which one would work. Okay?
Well, that's a terrific engine, Fred, and you did a wonderful job on it.
Well, thank you, John.
Remarkable, and I certainly appreciate your bringing that out here. And it's been a major contribution to the show.
Well, thank you. It was a pleasure to build it.
That was Fred Pritchard with his model from Plymouth, New Hampshire.
This is Jerry Swedberg, and we're here today to talk with Jerry about this fine engine he has. Jerry, can you tell us what make it is?
This is an Olds engine built by an old company from Lansing, Michigan.
Is that part of the Ransom Olds company?
Yes. In fact, Ransom Olds, he supposedly had this particular engine on exhibit at the World's Fair of the Columbian Exposition in 1893.
So this dates that back quite a ways, doesn't it?
Yeah, that's quite old.
Is this what you call a gearless Olds, too, isn't it?
Yes, it's gearless in the fact that right in here, you see this little ratcheting device.
Uh-huh.
One stroke, it pushes the exhaust valve open. The next stroke, when when it goes up, it misses in the notch, and next stroke it hits and pushes it open each time. And that's how you get your 2-to-1 gear ratio without having any gears.
Now, what's the ignition system on this one?
Okay, the ignition here is hot tube. Inside this tube, there's a metal pipe that is it's being heated by this blowtorch, and it's a spot on it is red hot, and that when the compression takes place, fuel comes up in the tube, it hits that spot and ignites.
Now, is this gasoline-fired hot tube?
That's correct, and you notice that the gasoline blowtorch has no pressure. The fuel pump pumps the pressure up to this level, then it returns. So it's only about, well, the weight of the fuel in about 4 or 5 inches is the only amount of pressure. But it's vaporized by going around inside of this blowtorch. It goes around and heated, and so there's only a very vapor coming out of the torch.
How long have you had the engine, Jerry?
I've had it since about 1987. I bought it when Andy Cruz, after he had passed away, I bought it from his widow.
Did Andy ever tell you what it functioned?
Well, I'm the 5th owner of the engine. And at first it was a man in northern Wisconsin, and then a SERP. A man in southern Minnesota owned it. I went to that auction. It sold for $900, but all I had was $700 that day. And then it went to Huxtable in Lansing, Michigan. And then it went to Andy Cruz, and then I got it.
And that has a pendulum governor on it also, doesn't it?
Yes. You notice this little pendulum here. When the push rod goes up, the velocity swings this little lever up and makes the hang-up work. If I hold it down,
misses.
See, then it will fire again. But when it flips up and pushes this in, then it'll hang up. So you can tighten this spring, then the engine will go faster.
You don't see too many engines with that real open crankcase on this cool little...
That's correct. This real open crankcase, you know, it's a cylinder, the frame, and down into here is all one piece.
You expect this is still the original paint?
To the best of my knowledge, yes. That's original paint from 102 years ago. Now, that's what everybody's told me. Everybody that's had it, that's what they always have said. More than that, hey, I can't remember that long ago.
Well, I don't see any reason not to believe them.
No, it looks very original. Even I don't think anybody even put in this little string lately. Do you? That's a filler cap there for the gasoline.
But for a gasoline engine, it doesn't smoke very much, does it?
No, it doesn't. Surprising. Of course, it would have to run a little faster than this if it was working hard.
Perhaps. Very nice. Jerry, we're pleased to have you with us today, and thank you very much for showing us your engine.
Well, thank you for inviting me.
This morning we have Jeff Hutchins with us to talk about his Columbus engine. And Jeff is from Tennessee. Jeff, can you give us a few words about your Columbus engine?
Okay, it was designed in 1895. It's a 1903 model, 6 horsepower. It's a very unusual engine with a lot of the designs. First thing I'd like to talk about is the carburation system. It is a vapor mixer here, and the fuel just comes up and lays in here, and it sucks the vapor off of it, and that's what makes it run.
Is there a fuel pump somewhere?
Yeah, there's a fuel pump, and it pushes the gas up, and there's no needle valve in it or anything like that. It just cuts off the amount of fuel that comes up, and it just sets in there, and it has to suck the vapor off of that into the engine, and that's what makes it run. If you don't have gas up here, we have this set up so the gas can run down through because it does overflow and spill out. If you don't have that fuel up there where it can get enough vapor, then the engine won't run. It's unusual in that over here on the igniter, it just smacks the igniter like this when it goes around, and that's what fires it. The flyball governors work and hold this little pin in place, and when that does it, it releases a clutch in here, and the end of the side shaft stops. And then it remains stopped until the engine slows down, and then this raises up, and then it releases the clutch, and the side shaft will turn, and it'll fire again.
That's kind of an unusual design. I think there's about 3 of those type of governing systems on different engines.
Yeah.
Columbus is one of the 3. Now, when this igniter works, when you go back to this igniter, that pulls together a set of points in the head. Is that
right? Right.
And then when it pulls it together, it closes the electrical circuit?
This pin comes up here, closes the circuit. This is a starting device here, and you prime it and you get it all ready to go, and you pull that down like that, and you bring it up on compression, and then you just pull that down, and it fires, and it'll start the engine.
What it really does is open the points and gives the electrical...
Right.
Okay. Interesting.
Right.
So this has both power intake and power exhaust valves, is that?
Right, right.
Huh? Do you know what it did in its working life?
No, don't know what it did. It came out of, it was found in Missouri, and we think it was maybe in a small mill, or in a grist mill or something like that.
What's the bore and stroke on this, Jeff?
I'm not really sure. I think the bore is somewhere around 6 inches, 6.5 inches. The stroke is probably 7.5 inches.
Again, we'll ask Jeff to tell us about this Bacchus engine that he has here. What do you know about that, Jeff?
Well, it's a 2 horsepower. It's a natural gas engine. Probably was used in a small machine shop or some type of operation like that. This engine was designed, we think, somewhere around 1894, 1895. This is serial number 1468, and we believe it's somewhere around 1900, maybe 1899, 1901, somewhere in there.
Is this the Bacchus company from New Jersey?
This is the Bacchus company from New Jersey, and this is an interesting engine in that it has a pendulum-type governor, and the pendulum swings back and forth when it speeds up, and then it doesn't inject the fuel in it. This one throttles under compression like the Springfield and the Foose, and it doesn't have a type hit-and-miss governor.
It also has 3 valves, I see here.
Yeah,
Can you explain the functions of those valves?
Well, it's a ported exhaust, and one of them is kind of a scavenger valve that it's a check valve that when the compression gets all the way back, it blows out the port on the side.
Huh. That's kind of a unique function, isn't it?
Yeah, yeah. Engine has quite a bark to it. We're going to start it up after a while, and we'll get to hear it.
Horsepower is this one?
We think it's around a 2. We've not been able to find any markings. Usually on a Bacchus engine, the horsepower is stamped on the timing gear. But we found no record on the gear at all what the horsepower is, but we think it's probably a 2 horsepower.
It's kind of got a nicely configured base under it, doesn't it?
Yeah, it's kind of a neat old-style early engine base.
Big shelf-mounted cylinder?
Yeah.
Very nice engine. Jeff, we certainly want to thank you for bringing these engines and your display.
We're glad to help.
Well, thank you very much. Pleased to have you.
Thank you.
Here we have today we've got Style Bradley with us with his Callahan engine, which is a very nice engine. And why don't we ask Style to talk to us and tell us about his engine?
Okay, this engine pumped oil in East Brady, Pennsylvania. It's a one flywheel pumping engine, which is a little unusual. It has an extra tall flywheel instead of two normal flywheels. I got the engine about 12 years ago. It was burned up in a fire, and the back bearings melted out of it, and it flopped over on its side, and it was kind of a mess.
What horsepower is this engine?
It's 10 horsepower, and
can you tell us a little bit about the ignition system?
Okay, this is the ignition system here. When this peg comes around and touches this, it closes a set of points in here. And when it jumps off, the points come open fast, which I have energized, and it sparks the engine. The unique feature about this engine is the camshaft, as you'll see when I start it, shuts off when it gets up to speed.
But this is what, an intake and exhaust valve? How does this work?
This is the intake. When the lobe comes up and pushes this, it gives it natural gas, or propane in this case.
But it also opens the valve on the other side of the flapper too, doesn't it?
Right. It opens the intake valve and the gas valve.
So there's a double function on this thing. It opens the gas. Okay, yeah, interesting.
And this is the exhaust lobe, and that pushes there and pushes the exhaust valve. When the exhaust valve comes open, and the piston's coming up, the exhaust gases go through the valve, back into the side of the cylinder.
It's a ported cylinder.
Ported, and come out here with the port. So two exhausts blow into one.
Interesting.
It's really an unusual feature. And yeah.
Okay, now how's this governor? Explain this governor to us again.
The governor balls fly out. Pushing a pin down, pushing this lever down, locks this lever over, and when the gear turns around here, there's a peg that comes out of it, and when that pushes a peg in, it shuts the camshaft off.
So it's a declutching mechanism?
It's a declutching engine. The gear turns, but the camshaft stops.
Oh. Well, this is the only engine that stops a complete side shaft for governing, right?
Right. Right.
Quite a bit of noise, too. Boy, that's turning kind of slow. What's the RPM of that engine?
I don't know, Nate. Probably
not more
90.
than 180, but right now it's running slow.
Yeah. Notice the oil reservoir here, and the cam's dipping oil. That saves on wear. This kind of
very nice engine. I like the size of that Callahan too.
Yeah. I think it wouldn't look quite as good with the double flywheels of 4 feet height. This is a 16-horse flywheel on a 10-horse engine. That's the way it came.
Stiles has a second nice engine to show us, which is an early Lambert. Stiles, what can you tell us about the Lambert?
Well, I got it out of Emporium, Pennsylvania. It ran some little shop in Emporium. It was owned by a collector for many years, and I got it about 2 years ago, and cleaned it up and brought it down here for the Coolspring to stay down here.
Is there any unique features about this engine?
This engine has 4 valves. It has an exhaust valve here, which is rather normal. Over here it has the intake valve. And here is the gas valve.
Oh, this is a propane engine then?
Right. And this is the atmospheric valve. What it does is when the governor balls fly out, it moves the cam roller over, and it fails to work these two valves.
Oh, there's a detent lever right in there,
Right,
isn't there?
right.
Okay, I see how that works.
And it fails to open these valves, and when it does that, it sucks the atmospheric valve and just sucks pure air in the cylinder.
And it purges out the exhaust fumes then.
Right, right. So then when the governor balls go back down, this comes over. As this cam follower comes up on the cam, it works these two valves, the intake valve, the gas valve, and then it doesn't work this valve, and it fires.
What would you say this is horsepower?
I think it's a 6 horsepower. It's a real early engine.
How far back do you think the design goes? 1892, 93?
Yeah, I would say, yeah. It's a nice old design engine. I'm really happy to have it.
Yeah, I can see why.
We can start it up, Nate, if you like.
That sounds like a good idea. Now Stiles is going to start this very old and unique piece. Get his oilers turned on. Ignition is on. And here goes.
Well,
there we are. Wow. Well, that does have some funny motion with that detent lever, doesn't it?
yeah, it kind of wiggles it all around, doesn't it?
Look at how nicely that leaf spring works. Wow. Then we got this detent lever that swings back and forth with the governor. It almost looks like it's loose, doesn't it?
Yeah, it looks like it's loose, but it works pretty good the way it is. It hardly ever misses a beat.
Well, you sure done a nice job getting this up and running again, Stiles.
Yeah, it was a little on the rusty side. If you notice how smooth a running engine it is, Nate, it's sitting on some wood cross beams there, and it isn't even wiggling.
Where was this engine manufactured?
The Lambert, Indiana, wasn't it?
Anderson, Indiana.
Yeah.
Well, I've heard a lot about these Lambert engines.
It's a real heavy-duty engine. Look at the size of the connecting rod.
We have Tom Buchanan with us this morning. And Tom, what can you tell us about this unusual engine?
Well, we think it's about 100 years old. It's very similar to the engines that were built early on in California.
Is that the vapor type engine?
The vapor engine. This is called a surface carburetor. And what they essentially did here was they filled this up with gasoline and sucked the fumes off the top. And that brass thing is a check valve to stop any backfires that would blow it up. The leather piece is an explosion diaphragm, just in case that didn't work. And although I'm running it on propane, because I think that's too dangerous to have around people.
Well, that's unusual. You don't see those on engines.
No, it's
particularly in the East.
Yeah, this one is copied from Daniel Reagan's patent of 1884. The California engines, Pacific and Reagan's, they had the valve chest at 90 degrees like this one does. This engine came from New York. Whether it originally came from California or was just designed by them, we don't know.
What can you tell us about that governing system? That looks rather unusual.
Yeah, it is. The governor drives this wedge into the intake valve and limits the amount of charge. Both.
In other words, it limits the stroke of the intake, the lift of the valve.
It limits the lift of the valve,
okay,
which of course limits the amount of mixture that gets to the engine. It's not very accurate because of the thickness of the wedge.
It seems to work well.
It does. When the engine takes off, it will stop it, but at slow speeds like this, it doesn't work very well.
That's kind of a nice and open crank on that engine too, Tom.
It has a brass connecting rod.
What horsepower do you think that is?
About 1.
Did you restore the engine?
Yes, I did.
Well, that's a nice job. Were all those engines, or any of the others that you know of, double flywheel, or are they all single?
I don't know of any other ones. There are any other ones of these. I don't think there are.
What kind of ignition system does that have?
This is an early version of a spark plug. It's called an inflamator. Lenoir developed this in the 1850s, right? Right, Nate?
Yeah, I would say.
I determined this engine had this at some stage, so I elected to duplicate that. It's essentially just like a modern spark plug. This electrode is hot, and this one's grounded, and there's 2 points come together, and it just sparks when it's supposed to. It's just a predecessor to the spark plug.
Well, they're just 2 parallel electrodes,
exactly.
And it jumps across the electrodes. Okay, I see how it works. So you got to have some kind of a timing function somewhere, right?
Yeah, there's a timer over here on the cam gear.
Okay. Exhaust valve looks like it gets a little warm.
Yeah, the exhaust valve chest is uncooled.
Oh, it doesn't get water.
There's no water to it, and it gets very hot. The compression ratio is very low also, and hence there's more heat in the engine. You're welcome.
Nice engine. Okay, we're talking to Bobby Lefevre here this afternoon, and Bobby Lefevre has a very nice 14-horse portable auto engine, which we'd like to ask him to talk and tell us about. Bobby, what can you tell us about this engine?
Well, it's 14 horsepower. It's about 1907. It's all factory original. This is the original auto truck here. One of the very few auto engines that's on factory portable trucks. It's probably used for farm work years ago. I don't know exactly. This tank up here is the cooling tank. There's also a blower over here that's supposed to be hooked up to blow air up through there to keep it cool. We're not using a blower today because it's just idling. I purchased this engine from AD Mast about 5 years ago, and really that's pretty much the history that I know about it.
Is this a gasoline engine, Bobby?
Gasoline, yes, sir.
Okay.
It's all original, paint yet, and that's the way it's going to stay, just like that.
But it's just outfitted with all the original auto oilers, too, isn't it?
Yes, sir.
Wow.
That's the gas tank up at the far end there where you sat on it and drive it with years ago.
Sit up on this tank up here?
That's exactly right. This is supposed to be an 1893 auto design. Serial number's 9668.
Oh, that's a nice engine. This here is what?
That's an igniter there, low tension ignition.
Is that a brass igniter, isn't it?
Yes, sir. That is correct.
I've never seen one of these without a standpipe before, have you?
No. You can see it's all factory original though too, so it wasn't cobbled up. Over here we have the clutch pulley that you could take the belt out of gear then if you're thrashing or whatever you're doing with it.
Huh.
Give this a pull.
So you could interrupt the power, huh?
Yes, sir. That's good.
That's a real nice engine.
Apple might even have the double tree to hook the horses to it yet if you want to pull it around the horses.
Huh. Okay. Well, Bobby, we want to thank you for bringing the engine out here to
Quite welcome.
Cool Springs to show us. We know you came a long way. Thank you very much. A beautiful engine.
Thanks.
Nate, this is a new era engine. I've had this for quite a few years and I like it. It was about an 1894 design by Lawrence Johnston in Dayton, Ohio. It's an early gas and gasoline engine with a lot of fancy doodads on it. It can run on gasoline through here with an injector pretty much like the Charter used, or it could run on natural gas through a control valve down there. It has an early make and break igniter with rather a strong action to it here.
That's a leaf spring, isn't it?
Yes. What we call a fast drop cam. That has to have a freewheel in it so the engine won't break if it turns backwards.
What horsepower is this?
10 horsepower. This engine pumps water for the city of Dayton in a suburb that was a little bit higher level. They needed more pressure than the ordinary city lines.
It seems to have extra large wheels on it for its size, doesn't it?
It does. I think that may have been standard at this time, though. This is earlier than some of the other new eras we've looked at. I've seen a picture of an engine just like this one on an 1897 flyer from the company. They were just then undertaking a 100 horsepower version of this.
This concludes the video of the Centennial Engine Expo here at Coolspring. We just saw John's beautiful new era run. And I think at this time we want to say special thanks to our show chairman, John Rex and Nathan Lillybridge, on the behalf of John Wilcox and myself, and providing just one super show. I would like to add that this was made possible by the cooperation of so many people all over the country to bring in their equipment from miles and miles around to have it here just for one weekend to run and to show and to make it available for everybody to see. We hope you like Coolspring, we hope you come to visit us, and we hope you like our video. Thank you.